Welcome back to another episode of In Depth with Academia. I'm Price, CEO of academia.edu. As always, I'm your friendly, curious guide through incredible world of academic ideas. Thanks so much for joining. I really appreciate you taking the time to explore research that might a little complex first, but I promise has something fascinating offer us all. Today, I'll be walking you through a paper by Rajiv titled Recursive Modeling of Reality, a Self-Referential Framework Integrating Information Theory, Dynamical Systems, and Artificial Intelligence. Quite a mouthful, though I'm here to make it as friendly and digestible as possible. And just to be super clear, as always, I'm presenting Singh's ideas neuter. I noting them. I'm just here to open the door for you, reflect and maybe get a little inspired. So's the big question or core problem that Singh is trying to tackle? Well, it's actually kind of profound. Most of scientific and computational models, the ones powering artificial intelligence, kind of treat the observer, or any system trying to understand itself, as separate from system being observed. This works for lots of problems. It hits a real snag when you want to model anything with feedback, adaptation, or self-lection, like the mind or smart AI, or even some biological and quantum systems. Why should you care? Well, if our models can't include reference and true feedback loops, they'll always up short in explaining, how living systems or really sophisticated AIs actually work. Singh's proposal is pretty ambitious. He sets out this recursive framework where a system doesn't evolve to some law. It also contains, internally, a representational model of itself, and crucially, changes by referring back to that self-model. It's like up a mirror, then making decisions based on you see. Every step forward depends on not only where you are, but also how you think about where you are. Pretty wild, huh? So how does try to make this work? He pulls together ideas from three big areas: information theory, dynamical systems, and artificial intelligence. And, well, he tries to build a single tying them all. He brings in this idea called the principle of recursive necessity, which basically says, hey, if system wants to stable and organized, it needs this and forth between what it was and how it says itself. Imagine thermostat that doesn't just check the temperature, but also considers, it's doing it as a thermostat and adapts its own rules. Or in AI, think of a program that constantly checks and updates not just its data, but its own sense of self. If that sense... Actually, now that I'm talking about thermostats, I remembered my home smart thermostat once started trying to learn my schedule, and it went all haywire after a power outage, thought I was coming at midnight every night, so... I don't know, maybe models could help with those little AI hiccups too? Anyhow, back to the point. One key insight is that when you add this kind of recursion, systems making models of themselves get behaviors like self-organization, chaotic dynamics, adaptation, and possibly even the ability to generate creativity or emergence. Singh even suggests that could be a theoretical foundation for future AI systems that aren't just optimizing numbers, minimizing some error, but actually maintaining an ongoing, evolving sense of self. Not sure if that's mind-blowing leap or just the next logical step. Again, I'm not endorse this, just relayings in the paper. Let's talk practical value here. What does this mean for you if you're a student, a developer, or just someone fascinated by science? Singh's is an invitation to think differently whenever you're looking at a system, whether it's a piece of software, a brain, or even a social network, of imagining observations or measurements as happening from the outside. This idea nudges you to ask, what happens if the system can measure itself? How does that change the outcome? Wow, does that make things more unpredictable or actually more stable in new? Now, as a side note, I've always been fascinated by recursive patterns, nature, right? Like the way ferns are made up, smaller and smaller ferns, or, in language, way we can nest clauses within clauses. Well, more clauses. Sorry, that probably didn't anywhere, but I just find recursion so captivating. Anyhow, Singh is to that, all of this is theoretical and no model is absolute. That's something I want to drive home on this podcast. What is that academic research gives us frameworks, not final answers. His need, simulation, maybe even real-world engineering before we know if they're useful, but the heart of is making self-reference a genuine part of our models. Maybe we can bridge gaps in AI biology, and that have seemed baffling for decades. So to wrap up, remember, Academic research is about enriching the way we think, notating how reality is, whether you're pondering how AI could be more self-aware, you're curious about what keeps systems in the face chaos. Today's glimpse into Raj Singh's work sparks some wonder, maybe a skepticism, and above all, a new angle to explore. Thanks for listening to In-Depth Academia. I'm Richard Price. Stay curious, stay and keep these big, evolving ideas. Catch you next time.